Welcome everyone to Geometry. Today is Thursday, November 12th, and I have a couple things that I'd like to talk about. There's nobody in class, nobody on Zoom right now, so it's just whatever you guys have sent to me and whatever announcements that I have. Once I wrap up those, I'm going to go ahead and end the meeting. So the first thing that I'd like to talk about is attendance. There is no requirement for attendance, so the fact that there's nobody here in the classroom and the fact that there's nobody on Zoom is not a problem at all. Of course, I would like to see you guys. I think that's a much better situation, but there's no actual requirement of you being here, so that's fine, no worries. But please understand that if you're not here, I'm not going to stand in this classroom waiting to see if you guys arrive for the entire hour and 15 minutes. So I'll hang out for a little while. Right, class starts at 12:35. If there's nobody here by 12:50, I'm gonna go ahead and end the meeting and get out of here. So you're welcome to come to class and ask questions, whether that's in person or if it's on Zoom. Either way is absolutely fine with me. But please be aware that I'm not going to hang out waiting for you to be here. If you want to, if you find that it's 1:15, you're like, oh man, I have a question. I wasn't in lecture, but Dr. Reinhardt should still be available. Definitely should still be available. If I haven't gotten myself into something that I can't back out of, then I'll certainly meet with you and talk with you. Right? That's what part of what this time is for. But it's best if you are here, okay, at the beginning of class. So that way I know that you want to ask a question or that you would like me to be here with you while you work on your homework, and when a question rises, you can ask it. That's fine. And if you're working on your homework and you don't have any questions for the hour and 15 minutes, that's fine. I'll hang out. It's not a big deal. If there's nobody in the classroom, I might go back to my office and hang out with you, and that's fine. That's not a big deal. I'll work on something. You work on something. You have a question to ask, but you got to be here in order to do that. So I don't know. We got another 7 minutes before it's 12:50, so we'll see if anybody joins us today. But if not, I'll end the meeting at 12:50 and I'll get out of here. So just be aware that that's what's going on. Okay. The other thing is if you do have a question that you would like me to talk about during lecture, then you need to make sure that you email me the question and make sure that you email me the question with the appropriate subject. So the subject needs to be Math 3031, question per class, month, day, year. Okay, that's what I need you to have the subject be. That's exactly what I said in the announcement a few weeks ago now. Maybe I should send out an announcement just as a reminder. But I'm not hearing a lot from you guys, and so I'm starting to get very concerned. Some of you are not coming to class and not handing in homework. Some of you are, actually that's pretty much, I suppose that's the only situation. Some of you are not coming to class and not handing in homework. For those of you that are handing in homework, thank you. Please continue to do so. Anybody, keep in mind at the same time, homework is due every Tuesday unless otherwise stated. It's accepted on Wednesday, and then after that, it's not accepted. Okay. There was one assignment that I left open unintentionally, and there were some submissions for it well beyond the due date. So if that was you, know that I might grade it, but you also might not get any points for it. So just be aware of that. Homeworks are due Tuesday. Wednesday, they're late. There is a penalty for being late. I haven't applied that very frequently. On the last couple of assignments that I graded, I did do that to some people. I was consistent on any assignment that I gave marked off points for being late. I made sure to do it to everyone that was late. So I was fair in that way. but I didn't necessarily remove points from every assignment for being late. So I think I did for assignment 17, but not for assignment 18 is what I mean there. All right. Homeworks, yeah. Make sure you're doing your homework. Submit them on time would be best. And that's it for homeworks. Attendance, again, make sure if you have a question that you're actually here. That's what I would expect. And it's okay if you're not here. If you have a question that you'd like me to talk about, make sure you email it to me. And if you happen to not be in class to ask the question and you happen to not email me the question, you can still stop by during office hours or schedule an appointment with me. My office hours and appointment availability are given on the syllabus, so you can find that on Blackboard and follow along with that. You can stop by my office during my office hours. We've been encouraged to meet with students face-to-face as little as possible during office hours. But if it's just you guys, it shouldn't be too big of a deal. So I'm not too worried about that. And then as far as appointments go, some of them will have to be by Zoom, but when I can meet face-to-face, I'll do that as well. All right, so I think that's all the announcements that I had. Well, I guess it's not. Don't forget about the exam next week. Okay, the exam will be up through section 20. So there are some questions that remain, it appears, on section 20. That's the only one I know about because it's the only one that anybody's emailed me about. So I'll go ahead and address those because someone did in fact email me. Now, they didn't quite use the right subject. It was okay, but I almost didn't think to talk about it during class today because it wasn't specified as a question for class. So I'll talk about these things, but keep in mind in the future that you need to, in order for me to talk about them, in order for you to say, oh, Dr. Reinhardt will talk about this during class, you need to make sure that you email me saying that it's a question for class. The responses by typed email can be not the best. It's kind of difficult at times to share what's going on. And it'd be very difficult to show you how to use GeoGebra by email. All right, so I'm going to go ahead and share my screen with you guys. And you can see here that we're taking a look at section 20. And I asked you guys in the lecture or in the content video to go ahead and take a look at this computer exploration. And this exploration is just looking at the relationships between arc measures and angle measures, in particular inscribed angle measures. And yeah, okay. Yeah, for the most part, inscribed. There are some that go beyond that as well. Anyway, so the first thing we need to do is download this GeoGebra file, and that is available on Blackboard. So let's see here. We go to Blackboard. I'm not sure if I'm logged in here. Let's see here. I'm not. So if we go to Blackboard, select our course, and then go to content. This is part of the second half of the second unit, and we go to content videos. You shouldn't have a problem downloading this file. So if you do have a problem, feel free to email me and let me know, and I will do my best to get that to you, get you able to look at it. So you can download that by clicking on it. All right. If you have a web browser or web browser settings set up in a particular way, it may prevent you from downloading that file. So be cautious of that. Make sure that your internet settings are appropriate. All right. So once you download that, you can go to GeoGebra, select on the Geometry tab. So if you go to GeoGebra, You can select the Geometry tab. And once it opens up, you can, on the left side, select Open. And then you can open from the computer, wherever you downloaded your file to be. For us, it is, okay, Inscribed. So I can open that, and it might take a moment, but there it is. So now we compare this to what we were looking at in, excuse me, in our lecture notes. So let's take a look at theorem 20.18, so the inscribed angle theorem. Again, we're looking at the relationship, as the directions say. We're looking at the relationship between the measure of an angle and the measure of the intercepted arc. So we're looking at the measure of an angle. So for this theorem, we're looking at these three cases. We have an intersected angle, or sorry, an inscribed angle, and then we have the intercepted arc. Inscribed angle, intercepted arc. Inscribed angle, intersected arc. And let's see here. Oh, and actually, we're talking about the inscribed arc of APC. APC. So the first case is that the origin, or the center of the circle is contained in one of the sides of the angle. The second case is that the center of the circle is in the interior of the angle. And then the third case is that the center of the circle is not in the interior of the angle. So those are the three cases that we're looking at. But no matter what case we're looking at, we can go to here, and it looks like we can move this point. So let's say I look for something that definitely doesn't have the interior angle. Essentially, all that the center is not contained in the interior of the angle. So if I try to get this at a very nice number here, I'm looking for a relationship between this angle measure, beta, and alpha. And you'll notice, oh, hey, look, how are 26 and 52 compared? 52 is about twice as much as 26. What about if I change this? Let's change it to 50. Look, beta is 50, alpha is 100. So yeah, this guy appears to be twice what that is. So our intercepted arc has twice the measure of the inscribed angle. So we go to our lecture notes over here, and we say the measure of an inscribed angle is, I'll type it in here, is twice that, or sorry, the measure of the inscribed angle is half the measure of the intercepted arc. Excellent. So that's what we discovered by going to GeoGebra and playing with these, because this is an intercepted, or this is an inscribed angle, and that is the intercepted arc. So we're able to look at that. Excellent. So that's one of them. I'd like to take a look at another one. There's a question about Corollary 2024. So hopefully that previous example helps you know how to address this particular problem. And then what we can do is we can also consider, we'll also look at this one. So we have, considering this figure, if CA and CB are tangent, then, right, we're interested in this angle measure and the intercepted arc. That's what we're talking about here. So this angle measure and that arc. So let's take a look at this. And we've got, let's see here. We can move that guy to right there. Oh, it's going for that whole measurement. So that's maybe not what I want there. So this one is tangent. And that's where it would be tangent as well. Interesting. Oh, I see. K is this side and lambda is that side. Is that right? Interesting. So you might have to look at limits here. Let's see. So this one already has that it's tangent. If we were to look at this one instead, looking for where they meet, that would be undefined. Okay, no. And then move this one over. So that way it is tangent as well. So 236 and 57. How do those compare? Yeah, no, that seems to be about right. This measurement is 4 times that measurement. That's about right. And that's kind of what we were looking at here, 62 and 240. So that's about the same. Interesting. All right. So anyway, what we're looking at here is when we consider CA and CB tangent to this, then APB compared to that appears to be 4 times the quantity. So let me check this. I'm going to open this up. Let me stop the share a second, actually. That way I don't give away too many answers. Oh, interesting. That one's a bit different than I expected it to be. So let me tell you what we have here. And actually, I'll share the screen and go ahead and write it on there. Here we are. All right, so we've got that the measure of angle C here is actually equal to 1/2 of the measure of arc AP B minus the measure of arc AQB. So that's interesting. So that may have been a little bit difficult to observe. So I'm glad that someone asked about that. Hopefully those of you that hadn't asked anything maybe figured it out or now are happy to see what that is. Excellent. Excuse me. So the measure of this angle is 1/2 of this minus that. Awesome. And there might be a little bit more that we could say about it as well. We could certainly investigate that and take a look more at it. And maybe that would actually require that. Maybe that would actually require us to go ahead and move a little bit more. So in this case, let's see if I moved that guy and this guy to be the same. Now we can see that this is not necessarily this measurement, right? This is not 4 times that. So hey, you know what? Me thinking it was 4 times, that's not quite right. Awesome. But we can see now, right, as we move this thing and this, let's see, to where those meet. All right, we've got 242.78 minus 116. Let's see here. $242. Minus 116. Oh, maybe put some parentheses around that. Divided by 2 is 63. Hey, look, that's what we have. Awesome. Anyway, so hopefully that answers the questions that you guys had about using GeoGebra and about that particular corollary. So if you have any other questions, feel free to email me. Make sure you use the correct subject. That way I know to take a look at it during lecture. And I will see you guys all again soon. At the very least, well, I suppose maybe I don't have to see you at all, right? We don't need that for the exams either. But don't forget about the exam next week and make sure to ask any questions that you have. You guys have a great weekend. I'll see you soon.